Recently gave a talk to the Young Stars program about the 2 years of data we've gotten from the TESS Space Telescope and what we've learned from this mission, which was designed to look for exoplanets, but has found a whole bunch of other stuff along the way. The session is online on both my channel and the Young Stars YouTube channel. I recommend you subscribe to the Young Stars channel, which there will be a link to in the description. This channel will upload all of the talks that happen, so you can catch up on ones you've missed and ones that happen in the future. We have a wide variety of fantastic scientists who are talking about topics which are fascinating to pretty much everyone, I would say. In this session we had so many questions, we didn't get through quite all of them, so I'll just go through some of the ones which we missed out right now. The first question is, are there any exoplanets that are larger than the star that they are orbiting? I'm not sure that there are any that we know of, because it'd be quite unlikely for this to happen. The distinction between something being a planet and a star is reasonably simple. It's just how massive the object is. For something to be kind of like a star, it needs to be around 13 times heavier than Jupiter, the biggest planet in our solar system. But for it to really be a star, it needs to be on the order of, say, 100 times more massive than Jupiter, so quite a bit more massive. The small stars are actually quite small, so their radius might be on order the size of Jupiter. So it might be possible if you were to have two stars trying to form, one forms into a small dwarf star and the other forms into a really big puffy gas giant, that the radius of that big puffy gas giant might be a little bit bigger than its companion star. But in general, planets should be smaller than their stars because they're made up of the stuff that's left over from the star itself forming. The next question is, have people been able to look closely at the surface of exoplanets? At the moment, the answer to that is no. The closest we've gotten is measurements of velocities in the cloud layers and albedos of some very big gas giants that are nearby. That's not really the surface detail of an exoplanet. There was one really cool paper that came out a few years ago on the topic of TESS, which used light scattered into the TESS cameras from the Earth to characterize the surface of Earth. And they used information like the bouncing around of the scattered light to tell us what the reflective parts of the Earth were, and they were able to build up kind of a loose map of what they expected the surface of the Earth to look like, which was kind of similar. So in the future, perhaps if we have some really strong telescopes, we might be able to start to get some information on the details of the surfaces of these very interesting worlds. But at the moment, we've got no such cases. The next question is, how do you determine the habitable zone around a star? It's actually pretty easy to do. So the habitable zone is kind of a hand-wavy term, which isn't too strictly defined, but you could say it's the area around a star where the energy output from the star is high enough that water won't freeze into ice, but also low enough that it won't boil away. So this region around the star is what we call the habitable zone, and you can calculate this by measuring the spectrum of light that comes from a star and determining its temperature and its energy output, and those things will tell you what the habitable distance will be from that star. But there are other complicating factors, like if the planet has an atmosphere and things to do with the nature of the components on that planet itself. If it's got no water to speak of on its surface, then there's really no point talking about a habitable zone, because on Earth, water is the main solvent for life, and if it doesn't have water on the surface, then it's probably not a good candidate for life being there. Since we talked a little bit about black holes, there were an awful lot of questions about black holes, of course. And one of those questions was, what are wormholes? Wormholes at the moment, unfortunately, are just a product of theoretical physics. You need some conditions which we don't think could exist, or at least we haven't seen in the universe so far. But a wormhole, in principle, is like a tunnel through the universe. You go through one side of a black hole, which is one end of a wormhole, and you'll pop out the other side, which is the other end of the wormhole. And you can think of it like going through a tunnel through a mountain instead of climbing over the mountain and climbing down the other side. If you were to climb the mountain, you would have to walk a much greater distance up and over the mountain than what you would need to walk straight through it. So that's the principle behind wormholes. But unfortunately, we have no observations to confirm the existence of wormholes so far. So there are only a few questions that remain, so I'll try and go through them as quickly as possible. The first one is there an exoplanet that is in the Goldilocks zone? Well, there are tens of exoplanets now that we know of that are in the Goldilocks zone and around Earth-sized. Next question is, how old can a star be? Well, that depends on how massive the star is. Really massive stars will live fast, die young, only living for maybe a few tens of millions of years. Stars like our sun will live for 10 billion years. Really small stars, like the ones that TESS is finding lots of planets around, could live for upwards of trillions of years. So these things will be around for pretty much forever. And the last question that we have is, what did I do at university to get my job? Being an astronomer at the Space Telescope Science Institute, the place that runs big space telescopes like Hubble. What I did was an honors degree in mathematical physics at the University of Canterbury, and in that I just took some physics courses and some math courses, and after that I went and did a PhD in astronomy/astrophysics. So that's kind of what you need to do, but it gets a little bit tricky after that point. You need to work out if you want to stay doing research after you've finished your PhD, and then try and find a place which offers projects for you to do that are similar to what you're interested in and that your skills can cover. So that can often be very challenging. So I got quite lucky in finding my job at the Space Telescope Science Institute, and in a few years' time I'll need to go through the same process again of looking to see, well, first, if I want to stay doing research, and second, see if there are places that I want to go to that are doing the same kind of research that I'm interested in at that time. So that's the remainder of the questions that I had from the live stream lecture. If you want to check out those live stream lectures, they're on my channel. Links will be in the description, as well as on the Young Stars YouTube channel. That will also have links in the description. If you have questions for me to answer in, say, future videos, feel free to leave them in the comments below. But for now, thanks for watching.